So let's start with example 1. In example 1, I want to calculate the total surface area of this cylinder. Now, I could break this up into its net and deal with it again, but remember we have a formula here. TSA is equal to 2 pi r squared, so that gives us the area of the top and the bottom, plus 2 pi RH, which gives us the area around the outside, this bit here, because this is 2 pi r and this is h. And so now I just need to substitute into this formula. So that gives me 2 pi times 21 squared plus 2 pi times 21 times 30. And if I evaluate that on my calculator, I get 6,729.2915 centimeters squared. Now don't be afraid, if you're dealing with values that are 2-digit and we're doing an area, well, you're going to be multiplying 2 digits by 2 digits. So if you get a 4-digit value, it feels a bit large, but don't be afraid of it. It's in the ballpark. It's the right magnitude, so it's what we expect. If you've got a 1-digit value, then we know there's some issues. Okay, now let's have a look at example 2, a little bit more complex and deliberately more complex. So in example 2, I need to calculate the surface area of this shape. I'm going to break it down into pieces. And so surface area of more complex shapes, often you'll have to do these pieces. And I'll try and do them by colour. So let's start with green, which is going to be this side wall here. And there is an equivalent one on the back here. And so in green, which I'll call area 1, this is equal to 20 times 35 times by 2. And of course, this is equal to 1400 centimetres squared. And then in blue, I'm going to have a look at, let's say, the front faces here. Front face there, and there's another one in the back. So area 2 in blue is 20 times 12 times 2. And 20 times 12 times 2 is 480 centimetres squared. And then in this sort of reddish colour here, I'm going to do the base. And it's just one of these bases underneath there, because the top, which would normally match the base, is actually changed. It's covered by that semi-cylinder there. So we have area 3. And area 3 is equal to 12 times 35, and there's nothing more to it. And that's equal to 420 centimetres squared. And then we have area 4 and area 5. So let's start with area 4, which is this shape here. This front semicircle and back semicircle. And so I'm going to call this area 4, and it's going to be equal to 2 times that semicircle. The problem is here we have to calculate the area of a semicircle, just half a circle, so we need to calculate pi r squared. But what's r? That's our issue. So let's have a closer look at this. Now I've kind of broken it up a little bit and made it a bit hard to see, but let's imagine we're looking at this side length here that I've just highlighted. That side length is equal to 12 because it's the same as that side length down there. And that's also the radius of our circle. Oh, my apologies. That's also the diameter of our circle. So therefore, the diameter of the circle is 12 and the radius must be 6. So area 4 is actually equal to 2 times a half pi times 6 squared. So I've got pi r squared here and a half because it's a semicircle. But because there's 2 semicircles, one on the front and one on the back, I'm dealing with 2 times a half, which basically means I've got one single circle. And so this is equal to 6 squared being 36 pi centimetres squared, which I could evaluate, but I'm not going to yet. I don't want to lose accuracy. And lastly, in orange, I've got this shape here. And this shape is equal to, and if I just pop a little highlighted green line up there, that's 35. It's the same as this length here. And in light blue, I've got this side here, which is half the circumference of my circle. And again, if I've laid that out flat, it would be a rectangle with a 35 length and a half the circumference length of the circle in light blue there. And so my area for this shape, area 5, will be equal to the circumference, or half the circumference, times by 35. And so in this case, that's equal to a half times the circumference, which is 2 pi times 6 times 35. And so that half and that 2 cancel again. And this gives me 210 pi centimeters squared. And I can finish this question off now by saying that the total surface area is equal to area 1 plus area 2 plus area 3 plus area 4 plus area 5, and that's equal to the sum of all those areas, which are these values down here. And when I add all those together, it gives me 2,300 in numbers plus 246 pi centimeters squared. This is an exact value, and there is definitely a place for exact values in your working, particularly as you move forward in maths. Keeping an exact value means we maintain accuracy. So if you don't need to know the exact value right now, if it's a particular question in a context where you just need to know theoretically what the surface area would be, this is fine. If on the other hand you had to go down and buy some paint to paint the surface of this shape, well, you might want to walk into a paint store and not say, I need 2,300 plus 246 pi centimeters squared of paint. So instead, you might want to convert it, and in this case, it would convert to 3,072.8318 centimeters squared, and I've just done it on my calculator. Just a little note here, of course, I've stuck with 4 decimal places for both of my examples for those components, and to be honest, it really doesn't matter whether you do 4, 3, or 2. 2 would probably be a minimum, and if the context requires more accuracy, then go for it with more, and I just stick with 4 because it maintains that accuracy where I can. So there you have it, a couple of examples and some surface area of some simple three-dimensional shapes. All the best.